Music. It's all around us, but have you ever stopped to wonder, how does a tiny groove on a plastic disc, a strip of magnetic tape, or a shiny CD turn into the sweet sounds of Lady Gaga or Michael Jackson in your ears? Let's go back in time. Record players way ahead of their time. Everyone knows that music comes from grooves on a record, but how on earth can a groove on a plastic disc generate the kind of sound that makes your ears happy? It all comes down to vibration. Think of this. If you speak into a big horn with a stretched out balloon at the end, the balloon vibrates with your voice. That's basically what your eardrum does to let you hear sound. Now imagine taping a pencil to the balloon. As the balloon vibrates, the pencil moves along a piece of paper. If you move the paper at a constant pace, your pencil scribbles random lines. Congratulations, you've just recorded sound, kind of. Those scribbles represent the sound waves, but it's a one-way street. You can see the sound, but you can't play it back yet. Here's the genius. What if, instead of a 2D scribble, you make a 3D groove? That's exactly what early inventors did with the gramophone. Imagine Lady Gaga singing into a big horn that focuses her voice onto a diaphragm, a fancy stretched balloon. That diaphragm vibrates. Attached to it is a needle, which carves those vibrations into wax. Bumps and valleys form a 3D groove, the blueprint of the sound. The wax record can then be turned into a metal record through a chemical bath, and that metal record can stamp plastic discs, the vinyl we know today. The grooves contain all the information needed to reproduce sound. Playing the music? Just reverse the process. Spin the record at the same speed it was recorded. Drop the needle into the groove. The bumps and valleys make the needle vibrate exactly like the original recording. That needle is connected to a diaphragm, which vibrates in sync, and the big horn amplifies it. Voila! Lady Gaga in your living room. Modern record players skip the giant horn. Instead, a copper coil moves between magnets, generating electricity that goes to a speaker, which vibrates to create sound. Same principle, just more modern and precise. Fast forward to the 1980s, the cassette tape. Tiny strips of black plastic store Michael Jackson's magic, using magnets. Recording works similarly to vinyl but digitally. A microphone captures sound through a diaphragm, turning vibrations into electricity. That electricity passes through a recording head, which magnetizes the tape in patterns mirroring the sound wave. Playback is just the reverse. As the tape moves past the playback head, the magnetic changes generate electricity. That signal is sent to a speaker, which vibrates and recreates the original sound. Boom! Music in your ears. Then came the CD, the digital revolution. Instead of grooves or magnets, we store music as ones and zeros. Microphones record sound, converting vibrations into electricity. That electricity is then digitized. High voltage equals 1. Low voltage equals 0. A laser etches these digital signals onto a disc as pits and lands. To the naked eye, it looks smooth. When you put the CD in a player, a laser reads those pits and lands, reconstructing the ones and zeros into an electric signal. A DEC, digital to analog converter, converts the digital signal back into electricity, and your speaker diaphragm vibrates accordingly. The sound of your favorite music digitally reborn. From vinyl to tape to CD, the principle is always the same. Capture vibrations, store them, and reproduce them. What changes are the materials and technology, but the magic of sound remains. So next time you put on a record, slide in a cassette, or pop a CD into your player, remember, each song is a tiny miracle of physics, engineering, and human ingenuity. From Lady Gaga's high notes to Michael Jackson's legendary riffs, it all comes from vibrations amplified, encoded, and reproduced with perfect timing. And there you have it. From a pencil scribbling on paper to a tiny laser reading pits smaller than a grain of sand, humans have found a way to turn invisible waves into unforgettable music. Science, history, and a little bit of magic. If you love this deep dive into how music works, smash that subscribe button, leave a like, and share your favorite format: vinyl, cassette, or CD in the comments.